That is wrong. Use is not 2. We just jumped to 4-3 polynomial fit, if you ask me. Or not. No, we did not. Well, this cubic is from 0 to 1. Then we found 1 as local extreme. Therefore we called handle local extreme, which then set last extreme cubic to 0 because the cubic 0 to 1 was being used to find 1. However, that then saw that it has both a maximum and a minimum, so it asks for a new point in between 0 and 1. At which point last extreme cubic is still equal to 0. So this gets aborted by the handle divide last extreme cubic, asking for the point at 5.5 or a point at 5.5. And we only have the cubic 0 to 1, which looks like horizontal, down, horizontal. We get those values for 5.5. This initializes then 2 new cubics between 0, 2 and 2, 1. So at that moment, I would say there is no last used cubic anymore. Cubic used. There's no cubic used anymore. Maybe I should set it to chain end. Or simply not use it. It still has not made up its mind though. It wants to go for a minimum or a maximum. Apparently. Because the last call to handle local extreme didn't go through. Even though previously, I suppose you also did this. Can find that back. No. No, the decision was made by the call to find extreme, which is printing it like that. Returning a minimum because that extreme is closest to the center of the two given samples. Which is doubtful because the distance is exactly the same, but closest between quotes. Okay, and then after adding 2, it says choosing a minimum of the right cubic, that is the 2, 1 cubic, because that extreme, that is the extreme of that cubic, which is 1, is closer to the center of 2, 1, which is here. Then to the center of, close to the center of 2, 1, then the left cubic is from the center of 0, 2. So it still measures 14, sorry, yeah, 14. So even the cubic at 0, 2 was looking for the minimum, so apparently we already did choose to go for a minimum. Where did that happen? I think here. So it did not change his mind about the minimum that, yeah, it got cut off now, but did not change his mind about that it wants to go to this minimum. So we have a cubic that contains a maximum and then a minimum, and then you add a point in between, and then we still want to go to this minimum. And then obviously, it doesn't matter if you add it left or right, the mirrored same thing. The center of that, the center of the cubic between the new point that cut it in two and the point that we already had is going to be closer. So it's always going to use then the half of the previous cubic that is the closest to the local extreme that we were going to anyway, and therefore I would say doing the right thing using this one. And then obviously again we'll jump to the same minimum. I mean it feels like it can't go wrong, huh? So and then it calls handle extreme jump. That would be to jump to 14 again. Okay, so here again, that should be the same point, I suppose. Which then again should be close to an existing one. So it's going to say that then the new probe is going to be close to an existing sample. So we then reuse that, meaning that So we're reusing one. Okay, so now we are in one, and then there is no cubic on the right, only on the left. It's jumping to that one, which is again 14. So here was jumping to 14, and now it's getting, it's stuck there till we get again, even though doing this, it's still 14, which then means that the step is 0, and therefore we call handle local extreme again, like, well, that was done before already. Yeah, 14. Oh, maybe I can speed it up, but the actions are same. And then it says, remember the node containing the cubic that found this extreme. That is highly dubious, because cubic used was never changed, really. Or, oh, it is 2. It is correct. Sorry, it is correct. The cubic 2.1 was used last time to jump to this point. So 2 is indeed the correct cubic. Yeah. And the last extreme cubic is just, well, leftover from historic stuff. We're going to override that. Well, we just overrode that, so now this is also 2. What the hell? Oh, I didn't execute it yet, maybe. Nope, now it is. Bother now 2. Now previously this was true, because that last extreme, when it was still 0, also had a maximum. But now it doesn't anymore, of course, because we cut it in 2. So now we have here, we pass that, and then we set the 2 to being the local extreme. And W must be, well, it's 5.5, it's the last extreme. Wait a minute. Oh, yeah, never mind, not 5.5. That is the extreme itself. Now we are going to look for 3 samples around the last extreme. That should become 3, 2, and 1. 0, 2, and 1, I mean. And on this side there is nothing. So we will have a left node that is equal to 2 and a right node that doesn't exist. We start with the two samples that span the use cubic. So actually left edge is set to 2 and right edge is set to 1 for a start. I meant left edge without the thingy. 2 and 1. Usable symbols. We add those two samples as usable samples. Left edge is on the left of extreme. Yes. And the right edge is on the left of extreme. No. It's equal. False. And then we get remaining left samples and remaining right samples. So we want to have a certain maximum, so we have only one now that is on the left. So I think that this should become something like 1 less than this, so that should become 2 and that one is still 3. Two and 3. Also 2. It is assumed that if it is not right, then it is left. Sorry, if it's not left, then it is right. So since this was false, and it was false because it was equal, it's now actually assumed that it was on the right, whatever. So I subtracted that as well. 2, 2. It's not entirely correct. I should not have added 1, I think. But why not? I should not have added it because we have a +1 here. That's reserved for the extreme itself. I'm going to add that again. A negative scale. Ouch. No. It's a W value. The smallest W value for which the cubic is still matching according to scale. Then that's the smallest, so that would be 0, which is at -3. Yep. It's false. Hmm. Two. This is true. This is true. This is false. I mean, this is minimum. And this is also minimum. So opposite is maximum, minimum is unequal maximum. So this, the whole thing is true. This is false. Therefore, we go to 1206. Direction was left. Yep. This is false. Node is changed to 0. While not node is local extreme, true, and node has extreme, also true. So we go to the do loop again and test this. But now this is true. So we failed to find an opposite extreme because, well, the extreme exists, but this was not marked as a local extreme yet. And therefore we set node to, well, the one before end, which is 1 for some reason. Well, this is 1. And this is false, because we don't want to do anything anymore. This is false, this is false. Then we go to the other direction. No direction is right. Start was 2. I forgot what the case 3 was. That was false. Yep. So now false is unequal to. So that's true. 1169. So we go to 1171. And this is indeed true. If start, why am I testing start here? Oh, we're updating the start, yeah. Start is not a cubic, all it is, because we're still on 2. Plus plus start, now start points to 1. So this is 1, which is not a cubic. So we must immediately terminate. So this is false, and you don't do anything. There is no other direction. This was indeed the minimum. You want to keep track of the best minimum so far. Because we did find a local extreme now. Yep. So the new minimum is 14. It must be a minimum. We didn't have that yet, so this is true. So we set it to best minimum cubic is set to 2, because this cubic is the cubic that was used to find 1. So the cubic is 2. That's what we pointed to. If it was changed, no, well, anyway, it should be false. Now we're going to look for a maximum. In an unknown direction. I think H direction still unknown, undecided. Yep, so I'm going to fit a fourth degree polynomial. The quotient root should be at -3 and 14. No. Sorry, the fourth degree polynomial is a third degree polynomial, because the best fit is just this, which is a third degree. We are not counting that one, so we have one in -3, and the other one is, yeah, far away. Should be very far away. So the number of found roots is 2, which are -3 and something very, very, very far away. Both roots are on the same side as the found extreme. Well, it's by coincidence very negative, this one. So yes, because the found extreme was 14, right? And obviously both -3 and -infinity are on the left of that. So this is true. So we go to 14, 6, 8, which determines the relevant root, which should be -3, which is 0 then. Yep. If H fraction is unequal undecided, but it is equal to undecided still. So this is false, therefore we don't go into this. Instead we have case 2b. We need to jump to the relevant root and set opposite direction to a step in the opposite direction. Meaning we are here and the jump is to -3 and the opposite direction, and there is nothing on this side, so that should be set to this value plus the scale, which is 8.5. So 14 plus 8.5 is 22.5, which is kind of here. This is what went wrong. Because this was false. Therefore we go to 1488. Handle fourth degree approximation jump. Let's do a step here. Now we are in handle 4-3 approximation jump. We're going to jump to 14. No. We are in 14 and we're going to jump to -3. Extreme jump. Ref is just set to -3. Expected LW is set to 447. Well, it looks about right. This I guess is 447. Next, I have expected apparently now, yeah, well, now we did decide which way to go for real, because we went from W we went to that. We went from 14 to -3. So -3 is less than 14. No, this is true. Though we went left. No, well, it looks correct, huh? We went from here to there. So we are going left. Now what? Scale must call handle last extreme plus step for the opposite direction. So this is set to false. Is that all? Is that all? Jesus. I was falling over this. I thought it was a bug, but I'm just printing an undefined variable. So there is no bug. Okay, wait a minute. This is used. Going to be used here. It's assigned to the same name with an underscore. And the rest is then, yeah, assigning undefined things, but it shouldn't be undefined behavior, I think. Maybe I should delay the printing that. You just print it from here, from the set opposite direction. I'm printing it like everywhere. With other usable local extreme. No, it's a little different every time. On the wrong side. Okay, I also have an assert. It happens a little bit later. So this should be the second time that we call handle LocalExtreme 14. And then what happens? We have 3 of those. We find the 4th Greek polynomial. And we call handle 4th Greek approximation jump. Set h direction to the left. With one other user LocalExtreme. Well, that would be the 4th Greek polynomial. And then it says we will do a scale step in the opposite direction. So that's good. Initialize range 14. I think that the trick here is we found this LocalExtreme. We want to go to the left, but yeah, we don't want to add new samples here and stuff because there's already sample there and there's already sample there. In fact, we can immediately infer from the already existing samples that, well, the maximum is going to be 0. And that's the point of the current code. So the range is going to be this is exactly on top of it. So I think left of 2. If I say it must be left of 0, then nah, 0 is the 1. So probably should be left of 2. And this should be setting the left of pointer. And something while doing that it goes wrong because I'm calling has maximum with the type of unknown, which is not good. So we're calling as extreme order on left node type, where left node is 1, I think. Can't do that, and this is again the wrong test. It should test if the thing is a cubic, not if it is the end. Is cubic. Righto. It's not cubic. But is that correct? if we are going to write, then we start with setting write off equal to either left node or right node as a start. Depending on the extreme order. So if this is true, the has extreme order means that the left node has the next extreme type on the right. Then so if the left node has the next extreme type on the right, we want to use left node. No comments here, damn it. I guess the next extreme type was already toggled. That would help me understand this. Yep. Okay, so that's really the one that we are looking for then now. So if it contains two extremes, but the extreme that we are looking for is on the far side, then we're okay in using it. Yeah. It is with extremely deep concentration, understandable-ish, but by nobody else and not by me in the future. So I think I have to add ASCII art here to explain what is going on. And I'm just going to copy the problem that I had. I need 2 of them. No, damn it. I think it's no longer possible. So the right node is set to the first node that is larger than the extreme. Okay, so it is possible, thank God. Yeah. And then the left node is set to the one before that, if it exists. An inverted comma. Don't have that. I use a dot, I think. Yeah. Okay. So that's one case, and I want to have an example for where this is false. Yeah, I might as well start over. Starting over meaning blah blah. Let's put a dot here. And then I'm going down. 1, 2, 3, 4. And then up. And then I need dots enclosing boundary, and there can be a dot here. So we're looking for a maximum, so we just found a minimum, so the one, this one should be close to the minimum. I don't want to put it here because then you get something like that. I mean, it looks weird. What's this one? And then here you can take a little bit more distance, because it doesn't really need to be close to it. And then I need this cubic with has 2 extremes, just like this one, but in the other order. I need left node and right node still to be those things. So in the hope that we can make this work, I'm just going to start with stating that this is the left node and this is the right node. Also, we are, as an example, we are looking for a maximum, which means of the found a minimum, like here, we found a minimum. So extreme type is that minimum, that is also the case here. extra space there. So far so good. But this cannot be the last extreme cubic, because the last extreme cubic is not allowed to contain two extremes. So we can't have approached from this side. So it must be literally the mirror image. So I'm gonna make this the last extreme cubic. But yeah, we're talking about going to the right here. So we still do that. You know, go to the left, it's just 100% the same. So now I have to make a maximum here that we want to find next. Okay. Now this is also nonsense, I think, because the last extreme cubic would be this cubic. And of course I meant the cubic between these, so this must be actually pointing here. And then I should probably remove this one. Because, well, we would advance. Well, we can set it here and then advance to that one. Can't leave that in, I guess. Am I talking about left off or am I talking about left off? We're going to the right. Okay, and then we have to deal with the situation that we can't call this function, because we're doing that on left node, so that would be the situation where left node is not a cubic. I'm testing here right now, so that's bullshit. But I think that came from that we were testing if right node equals chain end, and if right node is chain end, then the previous node is not a cubic. So left node is not a cubic if right node is end. So I might as well test here if right node is end, but it seems to be more logical to just, we're using this, so just make sure that it is a cubic. But the big question is, if this fails, so we never even look at that, should he pick that one or that one? So if left node is not a cubic, then what is the situation that we would have? Well, it's literally that it can only happen if it is the last node. So then right node is end and does not exist, which is only possible if there is no node on the right of the extreme. I'll make a drawing for that as well, I guess, because it confused the hell out of me. Just copy this pretty close to it. Yeah, this still holds, because chain n minus 1 is in the last node. And then obviously this must also be extreme cubic. So it doesn't really matter if it is one or two extremes in this case, because if there is nothing, then still we are going to look on the right of left node. So it should be left node then in that case. And then we're left wondering if I can't do the same here. But I'm really only interested in testing if left node is a cubic or not. So if we have this situation and right node does not exist, then we also don't have last extreme cubic. So this situation can't occur. It can't occur that the right node does not exist for this specific case. And I can't think of another way to reproduce this. So this is the only other possibility, I think. Okay, which means that if left node is not a cubic, then we want to do the same as in the case at the top. That is, make a right of equal left node. So if left node is not a cubic, then we want it to be left node. So it's correct, like this. Yep. Or has extreme order, the maximum is on the right. So the maximum is on the right here, that one on the left. Yeah, the maximum is on the left. Yeah, and then this is going to the left. Which is slightly different, not exactly symmetrical. Because our cubic pointers is always a left node. But I'm pretty sure it works. I mean, if, well, do we need to repeat my ASCII art just to understand the line or not? See, so I'm left node is the cubic pointer of the cubic between left and right. So I still use left node here, but the direction is changed. So right changes into left, and the right node and left node are swapped. And of course we set left off instead of right off now. And then afterwards, right off must be the node before left off instead of the other way around. So left off is on the right of right off, and then here right off is therefore on the right. That's not what. Left off is the next node. Yeah, that's on the right. Left node is on the right of right off. So right off is on the left of left off, right? On the left, yeah, and that is previous. And advancement is also slightly different, although I can maybe, no I can't. Wait a minute, I thought. Yeah, we know we can't use this. I really have to look at chain begin because you can't decrement it otherwise. So as long as we can still decrement it, and yeah. Pretty sure that, well, it's correct. This is the main question here. To be honest, I don't think I can do it. I have to repeat the ASCII art. I don't repeat everything though. Is this pure laziness? I think it's pure laziness, isn't it? It's not really a good reason not to have a lot of comment. Okay, I'm gonna do it because I don't really see it, and it's so hard to test that I just want to make sure that it works without testing it. So now we're going to the left. I do want to have a left node and a right node with a cubic in between that has 2 of these. We must be in the minimum because we are looking for a maximum still. But we're going to the left, so now I don't want this, I don't want to find this maximum. So this is really more equal to the second example. But the ASCII art already was almost the same. The second example, meaning that we need to have this tail on the left. So we can call, say, this is not what you want to look for. Let's call this M. And then I'm going to make a maximum on this side. I want it, of course, to be exactly the same. And what happened now? Too far up. To 1 something. That comment is bullshit. So it must be something like it is on the left of blah blah blah. Yeah, it's on the left of left node. Still a not. Okay, so it's possible that this is the last extreme cubic, meaning that the cubic between this point and that point gave me this minimum. And the minimum is extreme W, which then has on the right, the first sample on the right is this one, and then the first one on the other side is that one. It's left node. Yep. And we want to go to the left from this point and find the maximum, which then would be this maximum, which means that we have to look on the left of left node. This maximum you want to find next is on the left of the extreme. It is on the left of left node, and it is not on the left of right node. Well, actually it is on the left of right node, but we don't want to do that because then we find M. So it's still probably not the same. I want to copy what I did above. Here we said this comment. That comment is then probably better suitable. So here we have left node points to a cubic with two extremes, yep. But left off, but need left off to be set to left node, because it can't be right node. That would cause us to find the maximum on the right of extreme W, namely M. Yeah. Okay. Do we also need the other case? Can I just go straight to not having a left node, not having a cubic on left node? It's completely impossible that we don't have a cubic on left node, unless right node does not exist. All right. That can still happen. Yeah, it's good enough. So if right node does not exist, then obviously it's also totally okay, if not required, to set left off to left node. Ah, that is different. Wait a minute. So if we don't have the problem that that this function is not defined, then we use right node if the extreme that we are looking for is on the far left, which is not this picture, but the other picture. I think I can use this picture. Wait a minute. I just want to. I want to do something such that we end up with left node, I think, first. So I'm going to make this left node. and this right node. And then if left node is not a cubic, so right node does not exist, then we can't get the type. And I want to use left node. And if left node is a cubic, then we still want to use left node in this case, which means that the extreme type that we are looking for is on the right. So the next extreme type was maximum. And if that is on the right, so you have here minimum and then on the right the maximum, then this is true. And then we pick the left node as on left of. That is, it must be left of this. Why? Because if we would do left of right node, we would find the wrong maximum. Can't be right node, you could find, yep. Okay. And as usual, we still crash. Can never work immediately. It's not crash, but assert, and it's a different assert. So what happened? I think we are again, of course, jump twice to handle local extreme. The first time we jump there, we find that the cubic that brought us to this minimum, which is the cubic between 0 and 1. Of course, this is the whole cubic again, but we used samples 0 and 1 to fit it. So I'm talking about the piece between 0 and 1. That piece contains both the maximum and minimum, and we can't have that, so we added 0.2 in the middle. So cut it in two, and now we have a cubic that only contains a maximum, and we have a piece that only contains a minimum. After that, and then using the second one, we jump again to this minimum, and then again, and then we see the step is 0, and then we realize for the second time that it is a local minimum. Yay! So then we call again handle local extreme 14. That is well, w value is equal to 14 there. And then we find 3 points that fit, that are usable for this fit, because, well, the whole thing is a cubic, so everything fits. Point 0, 1, and 2. We fit a 4th degree polynomial, which then, of course, is also just a 3rd degree polynomial. We have something floating point around of error-ish for the 4th degree, which then leads to a random this tiny little thing results in a random other maximum, which is just at plus or minus infinity, which is being ignored. So we just go to -3. That is the other minimum, other maximum. Yeah, the 4th degree thing has 3 extremes. That's one we just found, and the other 2 must be either maximum or maybe a minimum on this side, which is definitely ignored because we are looking for a maximum now. Anyhow, all arrows are aimed at this maximum here, at coordinate -3. And then we want to go there, because that's what my 4th degree fit says. And then we get attempt to jump to -3 thwarted, because it is not in the required range, -3 to 5.5. And indeed we see the red arrows here, which claim that our maximum must be between 0 and 2. Highly dubious, highly dubious. Right on this edge here of the range is perfectly okay. That's where 0 is, then that's the one what you want to find. So there's several possibilities that you can do now, all in the light of floating point round-off errors. It's never going to be equal, right? So either we should not have set this arrow, because it's too close to the point that we actually want to find, or we do set the arrow, but then consider 0 to be inside this range, because it's very close in terms of floating point round-off error, closeness-ish thing stuff. So which went wrong? Now, that depends on the answer to the question, do I want to have this range set? Well, I think I do, because if the range is not set, then we don't have a cubic, and we just have to approximate it. Sorry, we have to... I need 2 points to have a cubic, and then we can jump to the local extreme of that cubic. So if I don't have a range with 2 points, then we don't have a cubic, and then we just have to, you know, do a normal gradient, well, not descent, but going up. So make a step, and again a step, and again a step, and then every time we do that, we fit a little cubic, which is, well, like I said before, this is a cubic, so any 2 points give us the exact same cubic. So I would just make a little step, fit a cubic through that, jump to the maximum of that one, find 0, very close, say, hey, we might as well reuse 0. And then we get exact same problem. So I would again step and step and step forever. No fun. So what should happen is that we mark the range that works, and then we should consider 0 to be within the range, because it is good enough in the range. Now you can argue that what would happen if it is outside the range, but just a tiny little bit on the left. Then the range would not be set. I say the maximum is actually here. Then the range can't be set because there is no maximum in between these two. So then we would take a step, and the closer we get to 0, the better fit we get, and eventually we would get a fit that has its maximum indeed where it then actually is, where it really is. That already works, so that's not a problem. But what if it is an extremely little bit? Then maybe I would still want to set that range here. I mean, it's like a waste to do a step if I'm just a trillionth off here. I mean, there's no difference, right? Whether or not the 0 is exactly on the range or a little bit to the left or the right, that shouldn't make a difference. So I think I should set the range if the 0 node is super close to this local extreme, and we should find it if it is super close to the right off that we said. Both should be a little bit fuzzy, I think. Okay then, let's find the code where the write-off is being set. I think we just looked at that. No, that is, yeah, well, probably did. So that would be the one where we call initialize range. So I can go to the last restart point, which is here, 105. It just restarts the whole program and then runs until that counter reaches 105. And then rerun does not exist. It's not a GDB command. GDB command. It's a user command that I wrote myself, which works in combination with some C++ utility that I wrote. This one. And then we want to, oops, no, I don't have my breakpoint anymore. Oh, this run for a very long time. Oh, not that long. Yeah. Good. So break in initialize range, continue. And then find out what happens. What is H direction? Well, we are going to the left, huh? Yep. We said this is definitely the code that I just worked on. Yep. it's not fuzzy. I already know that. So we should make it fuzzy. So we set left or right of to non-existent, and then we do find the larger value, which is also non-existent. So now right node is chained end, which then of course means that the left node should be 0.2. Point one, I mean. Yep. So it is 0.1 is the rightmost node. Left node was 1. Okay, is that a cubic? No. Don't check. Are you going to the right? No. Do some magic. Set left off. We go to the left. Look for a maximum. I think it should be 2. Not even sure though. It's 1. Okay, so left off. Left off is set to 1. We are going to search for this maximum on the, and it must be on the left of 1. However, we can advance it one step because there is no maximum in this cubic here. So we go do this while loop and then decrement it. So now it's 2. And now we stop because it's not equal to chain begin, but the previous one does have a maximum. That is, go here, and the previous cubic, which is in the cubic between 0 and 2, does have a maximum. This might be already fuzzy because I'm not looking at the coordinates, I'm looking at the type. And I think the type is, so let's do a step until we get into SampleNode. SampleNode. The extreme type is maximum. Oh, oh right. I had expected it to be right max, that as in already knowing that this is flat here. So it kind of thinks that the maximum is really in between 0 and 2. Anyway, a maximum does have a maximum, so this should return true. the has maximum is going to return true. Because this bit is set. So I thought it was the right max bit, but it is not set. It is set. Suddenly out of nowhere it's right max. Where did I get my max from then? What did I'm an idiot, I think. Did I start talking after that? That's not the type of the cubic. That's the type of the extreme that we are looking for. Okay, so this, yeah. So this cubic is already marked as having an endpoint that is flat on this side. And I think I'm doing that in a fuzzy way. So even if the maximum was a tiny little bit off, I would still have marked it right max and therefore still have detected it. So that fuzziness is there then. So left off is now pointing to 2. I'll keep doing that. Left off is still, well, left off is not chain begin. Therefore we set right off to the previous one, which means that right off is 0. So right off is this one, and left off is that one. Yeah, so that is this range. Right of that and left of that. Oh, fuck, and I stepped over it. Move into range. What is W now? Hello. It's not -3, it's -3.00000000044. It's never going to be equal. I have to step into this function, so we have to start over, unfortunately. Rerun. Continue. No, quick enough. If left off is unequal chain end, alarm bells go off. Well, yeah, this should it not be checking if it has a cubic? Although that doesn't come into play in this case, because we're on the left, not on the right side. So again, left of was 2 and right of was 0. Neither is equal to end. We have a cubic. Yeah, duh. That's not the right way to check that. Let me fix that. Let's fix it in this window. The comment is correct. Yeah, well, it is still kind of correct actually. Yeah, okay. So yes, we have a cubic that is left and right over this range. So we have 0 and 2, and the cubic in between is that. And then it says, if the W value of this is not fuzzy, this is an exact compare. Probably should make this fuzzy. Let's see what the exact values are. So it wants to move into range. So only if this is less than W, it's out of range. So equal is allowed, apparently. must be left of 5.5. Well, 5.5 is never, ever, 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 ever less than 1.1 minus 3. Plus or minus round off errors or not. So it is totally left off, left off. Yeah, so this is left off, must be left off number 2. And it is, because minus 3 is left off, well, 5.5. The other one, however, if W is less than, or, I mean, W is less than the write-off, that's minus 3. Yep, so we did set in a fuzzy way write-off at minus 3, because we thought, well, this is close enough. And now we are comparing it exactly, and it turns out that the W value is on the left of that. So it's not on the right, it's 0.00000000000044 on the left. And out of range, yeah. I'm not even talking about, no, wait a minute, so equal is okay, but it's not equal. But who cares? Shouldn't we just move it in range then? Isn't that the whole thing? Move into range. So I would say, let it be a tiny little bit out of range or a lot out of range. I don't really care. So attempt to jump to minus 3, which should have been printed as minus 3 point lots of zeros 4, thwarted because it's not in the required range minus 3. The accuracy here is definitely not enough. Yeah, this is what was confusing us. However, now it gets even more confusing because now I'm going to do something that produces floating point round-off errors. Analyze cubic. Why handle extreme jump? Okay, I'm getting it. Yeah. 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 Okay, step 1, I'm gonna print full precision here. Vette. Quit. I've got the line number. Seven, 6, 8. Oh. Oh. No. What? position is 15. I don't get why it's not printing it. Why do I get here? Because of the skips that I set, I think. No, I want to debug labcwd and it won't let me. Downloading the source file and then not having it. Stupidity. Yeah. TDB is not up for it, it seems. So I would like to cast my O stream back to the buffer stream. But with errors like that, it's probably not going to work. Can try it anyway, I suppose. Just oh really? Fuck you too. Yeah, maybe just outside the 15 position. Should not be. Yeah, there it is. Jesus. Okay. And this range is closed, isn't it? I'm printing it as an open range. There's a minus sign here. Yeah. Print it as a closed range, and I think I just have a comma here. It's outside of it, not equal. Equal would be inside, so it is an closed range. I don't think it's a bad thing here that we do this instead of being fuzzy. Because, yeah, well, But then we have to do something that is gives a round off, possibly a round off error, after which it could still be outside of the range. Which then is not allowed. So I kind of have to clamp it to the range after this jump, I think. So the handle extreme jump. It's being passed an analyzed cubic, and we get extreme from that. eerste fuzziness. Silliness, of course. Compare doubles equal. Well, theoretically, made it a closed range, so. Yeah, so what? Now it passed? Christ. No. Not happy with that. I wanted to really fix it. Now with the equals, it's suddenly getting past this point. That is the solution. To test one of these bits. Why do I have 4 different functions and just something that adjusts itself? To the argument that you pass. Yeah, it's a bad implementation, this. If it is right, I have to shift it 2 bits. And if extreme type is maximum, I have to shift it 1 bit extra. What the fuck? Hi Mitchell. Branchless. I'm doing micro optimizations again. Damn it. Yeah. I must say I'm getting tired of adding friends here as well. Getting a shitload of these things. Oh, this is just extreme jump. But it's made private, of course. Can't call that directly. I'm not a masochist, but it starts to look like it. Look what I had to do. Just to protect, between quotes, myself from doing stupid things. I just want to assign this value because I just want to assign this value. Maybe I should just make this thing public and get it over with. Yep, I made them all so specialized that you just. The reason I did this was to avoid that I would abuse them for something else, and it's working. It's totally working. So instead of reusing a simple function that just assigns ref, I'm making more and more functions that all just assign to ref. Is that success? Not so sure. Not so sure. Hopefully there comes an end to these things. Wait a minute, I do have that. This is my range. This is to the left. This is to the right. The clamping happens when actually don't know. Actually, this is not correct. This is an extreme jump. So I really have to call extreme jump to benefit from the fact that we did all this. I must call this. I don't think H direction is helping me. What should be helping? What should be helping is looking at the next extreme type. Next extreme type equals extreme type minimum equals so now must test the type of left off to have a flat left. Pretty sure might as well leave it to caller, otherwise I'm doing double work again. Bup. I could use this. That would tell me which one is lower. Nah, it compares all LW values. That's not what I want. Yeah, I don't want to do it again, really. So the same thing here, actually. I can't say that H direction is not really part of it. I just want to know if it is flat at a given extreme type. So it should look like that. What the hell? Left off was tested here. No, then I might as well pass left off. But. Okay. Static cast type bits to test unequal 0, meaning that it is flat at the minimum, whether left or right. Yeah, and that's where I want to jump to if we are looking for a minimum. Let's rename this, however. Yeah, call to edit. Below handle divide last extreme cubic. Well, it doesn't complain about being out of range, but we get here, which usually means that there is something else wrong. This graph with my library Cairo window. High IQ required because I don't do a lot of documentation. I don't have time for that. Feel free to write documentation while learning this, and then we can, you know. So it does have documentation, well, a little bit. It is super cool, really, trust me. You want to learn this if you have Linux. If you don't have Linux, forget it. In fact, you need to have X windows, but if you have Wayland and you're a bit of a coder, then I guess you can port it and get it to work on the Wayland as well. I am not supporting Wayland because I don't have Wayland. If I ever switch to Wayland, and yeah, I'll have to add support for it, of course. If you need more help, join Discord. Huh? I mean, any compile errors that you run into are your fault, but it will save you a ton of time if you ask me instead of trying to figure it out yourself. In fact, I think if you try to figure it out yourself, you probably will just give up. Now, we don't want that. The best way is to clone from Git a project that uses KRuin. No? KRuin itself is just a Git submodule, so you can't do anything with it. Right. Yeah, well, in that case, you're gonna have a build system problem. This is also not out of the box. There's gonna, I mean, you can do it, absolutely, but it's gonna take weeks and weeks. And then after that, well, then you know CMake, and you know Git, and you know maybe even XCB. And you know, you have to learn a lot. You'll have to learn a lot before you get it to work. But I guess that's what you want. If you want to become a programmer. Okay, I'll be nice and give you a link to the only thing that uses it at the moment. So what you really want to do is use machine learning. Machine learning is using KRuin. You see the link here? This is a Git submodule. So on its own, it's just a library which is not usable because it is also using this and this and this and this. But all those things are only in the root project. They are not inside that one. So we'll never get it to compile on its own. But if you just start with this, well, I mean, so far of the 10 people that tried, I think 8 run away crying. They just disappeared. One talked about it and then gave up. And there was at least one person, maybe 1.5, that actually got it to compile. Yeah, maybe even 2, with my help. And because of that, I have actually a shitload of documentation about how to build it, because I wanted to help people to build it. So this is what you want to start with. And then if you, this is also what I'm working on. Huh? I mean, this is machine learning. Yeah. And then inside machine learning, you'll have the Cairo window submodule. And then if you go inside tests, you have these tests. And most of those use Cairo window. So then you can just look at how it is done after you get it to compile, right? So for example, run cubic Bezier. Yeah, you can even drag points and get a real-time update. So that's pretty cool, right? It's a slider. But yeah, and the main problem seems to be that if you try to compile machine learning, then you're gonna need, well, it just, at the moment, it kind of requires, what was it called? I even forgot. You don't need it. TensorFlow, yeah. TensorFlow CC. And TensorFlow CC, you can compile it yourself. I did that, but well, you between quotes. And the only Linux operating distribution that I know that has TensorFlow CC compiled for you is Arch Linux. And Arch is typically also for people who are not afraid to learn everything and become experts. Certainly, in the beginning, there was no way you could install Arch Linux without first becoming an expert. I believe they made it easier. There's now an install script, which seems to work out of the box more or less. But yeah, then you might as well use Docker if you want to start playing with it. Or you just hack it, and I mean, you try to do this and then it says, I don't have TensorFlow, and then you just hack the build system so it doesn't complain anymore, and then you can't build certain things, but you delete, because in the end you don't need TensorFlow. So if you make some changes, you can get the Cairo window, of course, working on and the tests here. They should all compile without TensorFlow, so you could just remove it from the CMake requirements. If I was you. And then once you have that working, then you can, then you have an example on your hard disk that compiled and works, and then you can start your own project where you use it, and then you just copy a lot of stuff, but you don't copy what you don't need, and then yeah, something like that. Well, yeah, well, I mean, this is easy too. This is easy too. Just my experience is that if people run into some error, then they stop instead of figuring out what's wrong. 99% of the errors that you run into is just because you didn't have something installed. But I made a list, really, that it's all there here now. So, like, let's see. Probably described in Docker. Even if you don't use Docker. Where's my list? No, Docker has it already installed, of course, so it won't make the list. I think you might have to I'm kind of surprised if the well, here it is. These packages are needed, but that's on an Arch Linux. We also have a list for what you would need on Ubuntu, but it's not here. Then you have to join Discord. So let's see. I go to Discord, Discord, and then I go to my server, and then we can go to project overview, and then we have Ubuntu. So if you would join Discord, you can find on the project overview channel this list, which are then the names of the packages that you have to install. Well, it didn't very format it nicely here. That list. Oh, what the fuck? I didn't even ask you yet if you have Linux or not. Do you have Linux? Now you're gonna tell me no, I'm on Windows, and I will feel like I wasted my time. In the meantime, I forgot what I was doing. What was I doing? Yeah, okay. Well, then just try to remove the requirement for TensorFlow from the CMake, and avoid trying to compile the machine learning stuff. Just compile the Cairo window test, which don't require the TensorFlow, because it's very hard to get the TensorFlow CC on Ubuntu. And yeah, but last time not required for Cairo window. Asking myself, do I want to take a break now? Or shall I just continue? Probably a break is a good idea. Probably a good idea. Yeah, I'm going to take a break, because breaks are necessary. I'm not sure what was wrong now, but okay, I'll just, yeah, I don't know. I'll just pick it up from this assertion after I return, I suppose. I am not actually going to take a break. Yes, I am, but I'm not going to get up from my chair before I lost the game, okay? Because, yeah, I'm addicted to not getting up from my chair. Kick the knight. Yeah, that was maybe not the best move. I should have put the queen here first. Although, nothing is clear, is it? How about I kick the bishop? Okay, that was definitely not useful. I was just afraid that I would push this one and take the pawn, I suppose. But I was attacked twice. A renewed threat. What's he gonna do now? Panic again? Or just play a6, a3? To play this pawn, of course, you will take it, of course. I take, take. And nobody's winning. I'll just have to castle. Looks like he just gave away a pawn. I take here and then we take to the knight. I take the knight and I think I get away with an extra center pawn. We take to the bishop, then my bishop hangs, but I then take the bishop, takes with the knight. I take there. My pawn is undefended. Oh, okay, so take. And the queen can take this pawn. Well, then I can take this pawn. The only problem is that then, with the queen here, I can't castle. But I can take my bishop back and then castle. I don't see the problem. I'm going to go for it. That takes the knight. Oh, that's also possible. So I take here, takes the pawn back with check and gaining a my bishop. I just gave away a piece. Oh shit. Unless I first kick the knight, of course. So now I'm going to kick the knight. Knight can't give check because then I win it back and I still have a pawn. Should have seen this one though. You could go here now, and then if I win my piece back, you could go there with check, but I attack it, so he doesn't want to have two pieces attacked. So he goes here, I take, he takes, and then you have again a problem that he's gonna take a check. Yeah, I'm a piece down. I really have to do something. I could kick this one, still check. That would not be a pawn then. Is he going to give check anyway? Is he going to give check? Oh, now he can go here. Well, I just have to take this. Yeah, well, no, it wasn't as good as I thought. Only one move. And now I didn't win anything. The double pawns, can't castle, and I did not gain a pawn. Damn it, man, so bad. Now the bishop is clearly going there. And of course I want to put a rook on this file here, but then I lose that bishop. God, I can't have that. So we must play this. Otherwise I can't move my rook to where I want it. No, I don't see really. Okay, wait a minute. This one is going to hang if I go there. Exchanging queens is maybe not that bad. I do want to go. Oh, is he threatening check again if I move my knight? I just have a bad position, man. It's just really bad position. Maybe I should just move my king here, far away from the knight. With a bit of luck, well, with my knight here and bishop here, I can keep this pawn. Nah, not for long. I would do that, but then I push the other pawn. Seems like a pretty safe spot. And now I can't move my knight because, of course, I can go here. Which is what I wanted anyway. So now I win a tempo. I did win a tempo, yeah. Now that thing is going to go back, of course, and then I can maybe move there and there. And then we definitely have a game again. Not sure we want to allow that. Maybe first develop my rook over here. It's kind of wins the tempo as well. Oh, double attack on my bishop. Yeah, that's damn it, that sucks. Thing can't even go anywhere. This is not good. This is absolutely not good. Now we can take this pawn. Okay. Running out of time here. Oh yeah, that was the reason I couldn't do that. I'm so winning on time. Yeah, I'm winning on time. This guy is so slow. Unbelievable. What is that? What was that? Now I'm +2. +4. It should be winning. I can take here a check. Running out of time. Let's not do that. You got to be fucking kidding me. Should have gone down. Unbelievable. Oh no. 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 I gave this away. Yeah, I did feel the time pressure myself at the end. Pretty sure that was not necessary. Here's a draw if I go back, but yeah, I didn't even want to draw, of course. White is winning here. Wow, white is winning. White is winning. Yeah, I should not have done that. Oh, yeah. Take the queen, defended by my bishop. That was the trick. Then he can't take hero's check. Totally winning here. Totally winning. Almost every move is winning, except giving up this pawn. I even thought about this move. That is not good, but the other way around is good. So if now he takes my bishop, which he probably would have done. Oh, then I can take with check. Yeah, if I'd seen that. If I'd seen... Oh my god, yes. If only I had seen that one. Just queen here. That was a good move as well. Okay. I will be back.